All right. Okay. Everything's good. I think some people will probably still trickle in, but we'll go ahead and get started here. So thanks everyone for joining us today, second day in a row. I feel really privileged to be able to introduce our guest this week, Dr. Marie-Josee Fortin. Most of you saw her seminar yesterday. But just briefly, Dr. Fortin's research is largely in spatial ecology and spatial statistics with applications to conservation. Dr. Fortin has been hugely productive over the course of her career, both in terms of the amount and breadth of projects that she's worked on herself, but also in terms of the amount of work that her work has facilitated for other researchers. So I find I use a lot of her work inspires some of the things that I do. I use material from her textbooks in the course that I teach. And yeah, so I think we're really fortunate to have her as a guest speaker. Last month, we were lucky to hear perspectives from an early career scientist who has been successful in his career so far. And we continue to be lucky now getting a different perspective now from getting some insight from a scientist who's been successful across a very productive career. Yeah, so thanks to all of you who have submitted questions for today's panel of one question and answer session. So similar to last month, if you were here, I've kind of tried to organize those questions. There were more questions than we will get to, so I'm sorry if we don't ask your personal question. But I've tried to group the questions into some of the same categories that we had as last month. So some origins and questions about your career path, any secrets of success or advice you have to share, especially with the early career and student scientists here. Some questions about your own research, applications to management, and a bit about what you see for the future of the field. So I'll try and ask some questions from all of these categories. And if there's time, I'll also see if anyone in the audience also has a question on the spot while we're in those categories, if you have anything that you would like to ask while we're here. So with that, I'll get started. So the warm-up question is, how did you make your way into spatial ecology and statistics?
Thank you. You guys hear me? Excellent. This is a question that come back to my high school, which is a little bit different in Quebec, where I was very strong in maths. And then we have a college 2 years, and I have amazing math professor again. So I say, well, I'm going to go to math, right? And a friend from my school was in math department, and I went to see his course. I sit in the back, right? I hide. And I find the lecture so boring. Sorry for the mathematician. That I said, no, I cannot do this. So, and I was not having enough money to pay my tuition for undergraduate, so I had to work. So I worked for 2 years, and during that I traveled as well. And I went to France, in southern France, in the Bordeaux region. And I was fortunate to do grape harvesting for a month in a vineyard that was quite self-sufficient. So basically I say, ecology, maybe that could be good. So then I went to you need to understand also in Quebec, the undergraduate is only 3 years, and we don't have the major minor kind of structure that the English schools have. So they had it, but no one was doing it. So I decided to do a minor in art and science that allowed me to do computer science, programming, and ecology major. And then I say, okay, I like this, right? Want to continue. And so I went to one professor that I had in undergraduate, and I said, I would like to do risk assessment, save the world, risk assessment, what is the state of the environment? and say, yes, 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 okay, come to do a master with me. And basically, when I arrived, he said, what about this? So he gave me a paper about spatial autocorrelation, and that's how it started. So he gave me a paper, read this, and I liked it, and it felt right. And yeah, so then I continue in learning by myself statistics, because mathematics and statistics is not exactly the same. And it kind of link my interest in geography, ecology, and statistic as well.
So I think we heard a little bit now for this next question, but how did you find your niche in spatial ecology and statistics? And maybe more so, has that kind of developed over your career or changed over time?
Right. I mean, I don't want to age myself too much, but I'm not young. So back then it was very brand new, right? So it was a completely new field. So I was at the front edge of this discipline. And there was geostatistics, which is a little bit different than spatial statistic. So basically, I just continued for my PhD. I went to Stony Brook, Long Island, and worked with Dr. Sokol on those issue of spatial autocorrelation again. And yeah, it's just continue, right? So I'm not this person that planned too much ahead. I like what I'm doing, and then I see opportunities and I follow them. So I would say I was just at the right place at the right moment, because nowadays all of you are doing those kind of analysis and you take it for, this is easy, right? But back then it was brand new. Yeah.
So the next question is, what do you find most exciting about spatial ecology and statistics? And maybe another question, was it working in the forefront of a field that was exciting, or the topic, for example, autocorrelation, that was really exciting?
I think it's the methodology, because again, I really like mathematics. And so even in my master, I started to realize that we can use connectivity. So K-mean with spatial constraint that imply connectivity. So already at my master, I was intrigued by networks, so topology. And then I think it continued through the years. So I use it to detect boundaries. And so the differences between adjacent location based on the network. And then when that kind of trend of looking at connectivity, I say, well, I do that with my boundary detection. So I flip them and I say, okay, I can do connectivity with it, with the network approach. And then it just continue, right? So the network theory, I think, was everywhere in my research in some high point or low point, but it was always there somehow. So network was maybe what was the most important research tools that I've been using in different ways and adapting to different contexts. Yeah.
So working in an area like that was on the forefront of a field, did it feel, I don't know, freeing, like you can do anything in this area if no one else is working there, or lonely, maybe no one else is working there?
Well, there were geographers that were doing spatial analysis. So people in GIS, people in, I mean, geostatistic. So I was not lonely. Never felt lonely, no. Sorry.
What is it like now that like a lot of other fields have kind of caught up and are and now taking for granted the things that were brand new when you were working on them at first?
Like anything, because spatial stat are not taught by a statistician, but more an ecologist, people think there's no assumption and they abuse the, the statistic. So I think the problem is nowadays there's R packages that are so fancy and you can get an outcome, But if you don't understand what are the assumption, what really is the question, the scope of the limit of the method you're using, you will use it badly. I'm teaching advanced stat, and when we arrive to analysis of variance, people will say, oh, there's assumption. People don't, yes, you need to test the assumption of analysis of variance. So I think to be a little bit more critical and use them wisely is what people should do. So I'm seeing just a lot of people using the method not the right way. Yeah.
Do you find yourself spending a lot of time trying to advocate for that? Or is it, I don't know, so far there's so much that there's, yeah, you can't make a lot of progress trying to push for that.
Well, I'm doing sometimes intensive course, and then the books are there. Hopefully people will read them. And I mean, when you have textbook like that, people email you from around the world and ask you advice. So I try to give as much advice as I can and guide them in the right direction, but I cannot offer a course, right? Sometimes, so it's targeted to the question they have, right? So I'm doing that a lot, each other month I receive an email, I'm blah, 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 Dr. Fortin, blah, 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 please help. Yeah.
How important would you say has mentorship been for you as a researcher, and how do you view your role as a mentor for your students and others?
Very good question. We don't do science in a vacuum, right? We have collaborators. In your lab, you have other people that are postdoc, other PhD student. So I think the help starts with your cohort in your lab. And then, because usually the advisor is too busy, unfortunately. And then you create your own network. And at meetings, you meet other students that have similar interests. And then when you arrive at, I don't know here, but at university where I was, they assign you a mentor as a professor. And then myself mentoring other professors, but of course, mentoring my student. And that's the part I like the most, is to help my student to be able to craft their question, to be critical about the scientific issues, and then to help them through all the phases, because you need maybe more help at the beginning of your thesis to decide the scope of the project, then you may be more independent in the middle. And at the end is the run, you need the fishing line, you need to write, you need to get to things. So it's really, you cater it for the stages of each student.
Before we move on to secrets of success, does anyone have any follow-up question or another question that they'd like to ask? All right, they're all burning for the secrets of success, obviously. Okay. As one of the premier spatial ecological researchers, the direction of your work often dictates the direction of your field. How do you decide which avenues of research to pursue?
Well, I'm not sure it's about success at all. But again, at first I was very tied to the assumption of the methods and make sure that I was following them well. And then I started with the spatial analysis of plants because they don't move. That's fantastic, unless there's a fire, of course, or something else. But then you can study their spatial pattern, and that's what the methods were developed for things that are not moving that much. But as a professor, a lot of students wanted to do conservation and were interested in animal movement or species composition, community assemblage. So then you say, how am I supposed to do spatial statistics with things that are transient or not at one location? So that's forced you to say, well, maybe now it's not spatial statistic anymore that one should use, but maybe other methods of animal movement, telemetry data, so on and so forth, home ranges, territories, delineation, or for find pattern analysis for birds, we use the nests of birds and the number of eggs in the nest as an information of the spatial population dynamic in space. So you need to find tricks to address the question when the data or the question are not going to fit the method. So often I modify methods to adapt them to the question that I have. So is it success? I don't know. I think again, if your goal is success, you need to at least enjoy the journey of the research that you're doing, because I never aim for success. I aim to do good research and to be having a nice system to study, nice student to work with. So success is maybe a byproduct, but it's not was not my main goal. Yeah.
What are some things you've learned over the course of your career that you wish you had known when you first started out in science?
Wow. That's a tough one. I'm not sure, really. I will flip the question. So to be successful, okay, so let's go back to be successful. You need to work wisely. What is that? So it's to be optimizing your time and to not be distracted to too many things, to focus to deliver what you're supposed to deliver. And if you're lucky and you write well and you whiz with the data analysis, you can do more. So I think work wisely is also to select as a graduate student, master, PhD, postdoc, young faculty. There's things that you should never accept to do when you are at a different level, right? But when we look at your CV, to have some initiative is good. So there's a kind of balance. You need to have some initiative, but not too many. So you need some side project, but not too many. So it's kind of equilibrium where you show that you are not just closing yourself and not collaborating with anyone. So I was early professor, the secretary, the treasurer, or the secretary of the Landscape Ecology Society. Well, now it's North America. So you offer to do those things. But as a new professor, you never, ever accept to do edited books, because this is a killer. So you need to work wisely is to, when you are at a different phase of your career, you need to have some leadership, but you need to show that you can deliver the work as well. And then only when you have 10 years, then you can do all those crazy things that you think are much more interesting than building your dossier for promotion. And then you can explore other things. Yeah.
Do you have any advice for students or anyone who feels like they haven't found like that one path or that one niche in their field to follow?
Right. Like I said, sometimes well, when your advisor gives you a project direction or a kind of direction, you need to realize, am I going to like that for 5 years if it's a PhD, or 2 years as a master? It's a long time. You need to really like it, because there's this period where you will not like it. So you still need to like that project or those questions. And there's nothing wrong to change questions. I mean, when you start, you have no clue. Everything seems appealing, right? And then you realize, maybe that was not so appealing. Maybe this thing, because you go to seminar, you see other colleague in your lab in other labs, and you say, that was much more, that's talk to me. So I think you should not, I mean, unless you cannot change project. I would give you an example. Jonathan Rupert, that I showed you the shark information. He started with me as a master student, and he wanted to work with marine species. And I said, sorry, the only thing I can offer to you is Atlantic cod in the Gulf of St. Lawrence. That's what I can offer you. But it started with that. And then I went in sabbatical to Australia, and I met a colleague, and he was working with shark. I said, I have the student for you. So I came back and I said, what about shark? And so he transferred to PhD and worked with the shark for the rest of his PhD. So that was an opportunity. That's what he wanted to do. I didn't have that. And then when you write your global introduction of your thesis, it's like, cod and shark, how are we going to sell that to, So then it was obvious, apex predator. So we could use the kind of apex predator as the framework to link all those chapters that didn't look that similar to start with. So there's always ways to, and let's say that you finish your PhD, say, I'm never going to work with that anymore. Well, that's why postdoc is there. You have a chance to learn new skill, to look at new system, and that's really the joy, is to say, now I want to reinvent myself in, I don't know, molecular ecologists or something.
So you have a pretty wide breadth in the topics that you work on. Is that something like that you would advise, for example, also with the postdoc, to, even if you think you like something, to explore a wider breadth of questions, or maybe, well, I don't know if you think it's like if there's a common theme even across the wide breadth of work that you've worked on.
Definitely. Again, if, let's say, another PhD student of mine, he was working on forest modeling, and he could not wait to get out of the lab. He was fed up. I want to get out. And he went to do his postdoc at another university where he was more looking at molecular insect dynamic. And he came back after 3 months, said, can I come back? So basically, sometime to go elsewhere, you realize that this was maybe not the best. We have in Canada, those of them that are lucky to have a answer scholarship, they can apply to a fund of 6 months to visit another lab. So that's an opportunity, because maybe the behavior of your lab is not the one you like, and you go visit another lab and say, oh, I like this one, or you appreciate more your lab when you come back, type of thing. This is not answering your question. I digress. What was the question?
So yeah,
Sorry.
well, I guess you are kind of getting to the question, was like, you have a wide breadth of research. Would you also advise?
Oh, yes, sorry.
A
I mentioned it to a few, sorry, I repeat myself, but this the T strategy. So you need to be known, your name need to be associated with something that people say, oh, this person worked on this and is known for that, is an expert on that. But then when you look for a job, maybe they don't need this expertise. So you do, right? So that's why you look for another postdoc. So maybe if you have a wider range of expertise, then you can say, but I'm known for this, but I can do this, to a limit, of course. And you need to be proportional to the state of your own research, right? You cannot just go over the board and be expert in everything, but showing that you have the breadth, you kind of see the bigger picture, and you can see the concept, the theory, and how you can modify from one system to another. So to be too specific, it could be a blessing if you're super lucky that they really need you somewhere, but it's the likelihood of needing exactly your profile at the time that you finish. That's the problem sometimes, is they need you, but they needed you 2 years ago or 5 years from now. So you need to survive, or you need to reinvent yourself a little bit. And once you have a position, then you go back to your heart and what you like. Slowly, but you go back.
So you mentioned the NSERC
Yes,
and the
that's the
6 month.
visiting.
Yeah, so there's one question about your views on some of the benefits or drawbacks of the academic or research system in Canada versus the States, and yeah, maybe where we in the States might be able to look for better ways of doing things.
Oof. Well, ANSERC is providing scholarship for the master, the PhD, and postdoc, and then for my grant. So it's this different level of it, but there's not enough of it, and the funding is not in sync with inflation, and people are very upset about that. But this is a minority of people that has that award of scholarship fellowship. So a lot of my students, I pay them for my grant. So they are paid the same way, but come from my own research grant. And once I look at two students, one that had a very more prestigious scholarship and another one that never had a scholarship, you could not tell which one was which. So if you train them well, I mean, the other person that had no scholarship had to do more TA-ship, but so he was able to cope with all this. So I think, I mean, ideally, we would like to have all of you guys to have scholarships. We don't have as many as we would like in Canada. Is it better? Is it worse? That's where I am. So that's the system.
Any other questions from the audience?
For that scholarship, would you encourage students from the United States to apply to try and get like a international camaraderie, I guess, between labs?
Well, I mean, have been hosting a lot of visiting scientists from all around the world, sorry. In Brazil, they have a system that can bring student to professor for 6 months or a year. I had a lot of people from Spain, a few people from France, people from China. So there are programs that make the possibility to pay for your trips and your stay. So those are a fantastic opportunity. If there is such thing, you should definitely take advantage of it. But it could be even within US, if you visit another lab that has comparable research interests, because each professor, we have a way to train and to interact that is maybe different than other ones. So it's good to see the different perspective out there. Yeah.
Right now we're switching gears to science.
Yes.
So would you say some of your own and others' work in ecological networks falls more heavily towards describing patterns? So how we usually start in like a new field where we're just looking at what the patterns are, versus explaining processes that generate those patterns? Or where do you see there's potential?
Wow. So in a new system, you need to describe it. If it's with network, with statistic, with name it, mapping, plot your data. That's rule number 1, golden rule. It's the first step. It's not the end point. It's just the first step. So regardless which technique you're using, it should be just telling you how much variability there is. So nowadays, again, the PhD, the master are shorter and shorter, so there's no luxury of pilot study. But pilot study would be fantastic to give you a feeling of the variability, the dispersal, the temporal dimension, but we don't have that luxury anymore. So then your assessment of what should have been the pilot study You look at your lab, maybe there's a continuation of expertise in the same system. So you ask in the lab people what they have as the data, or you go to the literature and see what people have found as differences. So I think this is very crucial because we want to improve science. We don't want to repeat what others have done. So we want to say, so-and-so find this, so can I have some hypotheses and predictions? So you say network, but it could be any statistics. It's not, network is just simplification of a complex system. But nowadays, people are making it more and more link, more and more nodes. So in fact, the goal was to simplify the system, and people add. So they make it complex that you cannot analyze it with the network approach anymore. So you need to go modeling or other approaches. So, but I think we want to advance science, so we want to go beyond the pattern. We want to look at what are the processes, yes.
And do you think there is much work like falling now more heavily on looking for the processes? Like, is that a bigger push now?
There's amazing research, yes, that is doing that. So even just by doing an experimental design of network of patches, like we want to do for the forest, my microcosm was a kind of way to explore the connectivity and arrangement of the bottles with the processes. So more and more people are doing this kind of using a simple model to test alternative hypotheses. So a group of researchers in Montreal, they did that and got published in Science. So it must be good. So you can manipulate things. So that's the beauty of it. And then how can you translate the knowledge from a microcosm to maybe a mesocosm and then to the real world? Well, each time you have new complexity and new dimension you need to account for. Yeah.
This next question has a long preamble,
Okay.
so bear with me. Centrality and connectivity have different meanings across network systems, for example, social networks or gene networks. Centrality in particular has two interesting definitions. The first, the amount of non-redundant information that passes through a given node. And the second definition, the amount of shortest paths from one node to another that pass through a given node.
Yes.
With these definitions in mind that you've all internalized, obviously, what would you say is the ecological basis of centrality with respect to habitat connectivity?
Okay. I don't care about whatever definition. For me, it's more this issue of the degree. I mean, in some statistic, everything is, if you're, I'm just going to give another example. If you want to assess what is the degree of fragmentation in a landscape, you need to know 4 statistics: the amount of forest, let's say, of interest, the number of patches, the size of the patches, and the distance between the patches. But it comes back all to those 4 statistics. So if you have that, you will characterize very well the fragmentation. In a network, it's the same thing. The most vital information is the degree of the node, how many connections each node has with other nodes. And maybe this could be weights. But then the shorter paths, well, okay, it's interesting. How many non-redundant, whatever you mentioned, fine. But there's all come back to the topology to start with the degree of the node, how they are connected to one another. So I mean, there's hundreds of network matrix that exists out there, and they're all a little tweak there, a little bit of tweak there. So basically, you need to understand what is your question, and for habitat, maybe, let's say in one study, we were interested in the caribou movement in Manitoba, in Canada, and we had color animals, and we say, well, what are the animal doing? Are they going to go in straight line to the farthest patch, or are they going to do stepping stone and look at the closest one and then move to the next one and to the next one? So we developed an algorithm that is kind of more aiming to the shortest distance from one patch to another. And then the reviewers say, well, why not just all distance, all connections? So I say, okay, we will show you that it was a dense patch network, no, so that's for sure a different context. But the difference in path length was 3% difference if we were looking at the stepping stone or the direct path. And you need to go back to what the animal will do. So the animal, maybe they will, I mean, the algorithm does what you ask. So in Manitoba, there's the Lake Winnipeg that is huge. And we had 2 sampling points. And if we had done Euclidean distance, they would have need to cross 20 or 50 kilometers of the lake to go. So it was ridiculous. So you need to adapt to the concept, what is maybe the least cost and the stepping stone to move from one patch to another. So again, there's so many subtleties about those matrix, and I would say they provide you more or less the same information. I'm not particular in one or the other.
The last part of the question was how might those different definitions be important for thinking about conservation? And I think you touched a little bit that sometimes you have to think about the animal, and maybe that leads you to, yeah, calculate some things.
Right. So I think especially if the animal move through the land versus birds that are flying. So for birds, maybe the quality of the patch is more important. And then the size of it. Then in another study from another PhD student, he showed that at one point, if the patches of forest were too far away, the birds would not go back to the nest because it was too much effort to go through the open and be maybe preyed upon by kind of eagle or whatever. So you need to understand the biology, and then so yes, it can be applied to conservation, but you need to understand the behavior of your species.
When looking at species interactions across multiple scales, do you often find contrasting results between different scales? And if you do, what are your strategies for communicating those different results?
Yes. Point pattern analysis is spreading of seed, and then there's different property. It can be a poisson generating process, poisson. There's many ways to generate the point layout in space. And then you may have clusters of points that at small scale, they're random, and at other scale, they look patchy. And then if you look at another scale, they look random again. So then this is an exploration that you need to work with the data you have. And so I would flip the question. With spatial autocorrelation, you can have a value of spatial autocorrelation according to distance. So the first law of geography is that nearby observation are more similar than distance one. So in the first distance class where you measure the spatial autocorrelation, if the value is 0, not significant, then you say, maybe I don't have the right sampling design. I was not able to capture it, or my spatial lag is too long or too short, right? So that's give you insight of you maybe didn't design the system, your sampling design to match the pattern of the species or organism of interest. If it's negative, that's also a signal. So you miss completely the positive autocorrelation, unless it's allelopathy, that's another possibility. So those are guidelines to show you that, oh, I have missed the mark in my quadra size, in the spacing of my quadras, and the analysis that I'm using. So.
Okay, now there's a couple questions thinking about conservation. So when thinking about conservation in a dynamic system, or more generally, a changing world, how do you think about a target state that is desirable, achievable, or resilient?
Um, So you may have heard, I'm sure, of now people call it the actor versus the scene filter approach. So either in my days, we were calling it the fine filter and the coarse filter approach. So the filter approach, you focus on the species or charismatic species, umbrella species, and you try to save that species and provide the best recovery plan for it. The scene or the coarse filter approach is you protect the ecosystem. And I'm more in that kind of spirit that hopefully if you have enough area and an ecosystem maybe is more interaction between many ecosystem from terrestrial freshwater to ocean. So you need maybe to have the connectivity throughout to maintain as much as possible animals or plants that are behaving in those ecosystem. So I think I'm in the favor more to save area and hopefully that will save species that live in those habitats.
I guess to me, it sounds like saving an area sounds intuitive versus saving an ecosystem. That to me sounds very difficult versus and saving maybe a focal species, target species also again sounds doable and something that managers would be familiar with working under that concept. Do you think yeah, so I guess is it suggesting what areas should best be saved or
Right. So, I mean, you all heard about protected areas, right? So, and now in Canada, we have this connectivity is part of protecting areas. So to have a network of protected area is the big buzzword in marine ecosystem and terrestrial ecosystem. And of course, fresh water is never accounted. Yeah, fresh water. What do you mean fresh water? But that's another story. But the point is that with a group of a working group, we propose to have a series of permanent protected area with transient ones, because the habitat will change, there will be disturbance, there will be succession, so you cannot predict exactly what the species needs. So you need more habitat than the 30% number that people say. You need more because some will disappear, and you need a stepping stone network of habitat. So it's I say ecosystem, but it could be an area, right? That doesn't need to be an ecosystem, of course. But again, there could be cases where there's no corridor to connect those. And in Southern Ontario, we have a lot of agriculture and not many places where we can connect area. So it's an issue that how the species are going to move if there's no stepping stone, small patches that allow them to move through the landscape.
so well, this is a big one. How do you manage to hold on to hope while also remaining honest and practical with your students about current conservation challenges?
Can we skip that question?
Nope.
Oh my God. I mean, small victory, we need to be a little bit positive, right? The small victory. And we need to cherish them. But yes, I mean, I'm teaching conservation third year, and each year I need to revise my slide in a negative way, which is very depressing. And the students find it very depressing as well. So you need to show some success story, right? So maybe one example was to restore oyster bed that are preventing tides to arrive to the shore. So that's commercial wind and there's environmental wind. So you need to, there's not many of them, but you need to cherish them and you need to show them there's possibilities. So I think you need to be optimistic because otherwise, well.
All right, any questions from the audience on science and applications? All right, we're getting to the last section, thinking about the future. What would you say were the biggest advances in spatial ecology and statistics that you've seen over the course of your career?
Okay. Again, the assumption of spatial autocorrelation is the process that generates the pattern is the same throughout the study area. And now with the globe and the remote sense imagery, people are using larger and larger study area. They use remote sensing. They want to address big trends and everything. So then there's a maybe an additive process. There's maybe regions, and you need to be able to maybe segment and create some kind of area that are more similar. And you need to say how many scale do I have. So now we have tools to do that. Again, there's assumptions that no one follows. But so to be able to tackle maybe issue that before was, the statistic limited us to this. So that's bring me back to the fact that you need to delineate an area that has some kind of properties that are the same. And now we have tools to do that, I would say. So that's positive and novel.
Are there any big ideas that you think that you've seen a shift to focus on different types of ideas now that you have these tools maybe?
Well, I mean, if you flip the page of science or nature, they really are liking all the globe maps of biodiversity and this and that. So that's also simplification because the pixels are huge, right? So you say, yes, there is so many species. But my question, I'm not answering your question now, sorry. But my point is that people are lumping many years of species data, and maybe some species don't exist anymore. So I think we need to be honest when we lump different data sets, different sources, we need to lump them properly. So there's a big tendency now to do a big data integration, and not many people do it wisely. So it's not answering your question. What was the question?
Well, I guess I could ask, do you have suggestions on how we could do this wisely? If this is if it's of interest to think about global scale biodiversity and other processes, are there opportunities for us to do it better?
Again, to be honest with the data that you're using, to state the temporal dimension of the data that you are synthesizing and this global scale, I think would be a start. And be honest, maybe you're not mapping the current state, but the past state. So maybe this is a way to say how much it's been degrading since. A lot of people like the group of GeoBond are trying to find better way to map biodiversity, and they want to do eDNA, drones. So drones are kind of nice because they're a little bit closer to the ground and they maybe offer you more, less distorted vegetation cover. And so drone has potential, but then you cannot have as many large study areas, right? So it's dependent on the question, I would say, yeah.
In your opinion, what do you see as the most valuable areas of opportunity for the next big advances in spatial ecology and statistics?
Drawing back the question, what is the question? I think if you have a good question, the tools are there. So I think we're not limited with tools. We may be limited with storage of megabytes with the Google Earth Engine. All my students are mining those database, and then they need to work on the cloud to be able to analyze that. So there's a lot of data manipulation, and then you can get lost in one line of code. And when you're about to submit the paper, you realize, oh, I made a mistake. So it's easy to make mistake with data handling. So is it opportunity? I think Google Earth Engine, it's a fantastic tool that if you know how to use it, will save you a lot of time. And GeoBond is trying to do a kind of interface where you don't have to download the data. You can work on whatever cloud it is, I'm not sure. And you can do a Maxent models, or you can write your script and then you make it available to everyone. So there's a lot of new platform where people are not just delivering the data, but want to have models that people can reuse and implement and adjust. So this is new opportunity that, you know, if you don't need to download the data, my God, that's so much better.
So with the amount of tools and data that are there, are there big areas of questions that you think are the most ripe for opportunity? So for example, global questions seem like they're uniquely enabled. Are there other areas or particular areas that you think are valuable to look into?
Your conclusion are going to be based in as a function of the cell size, pixel grain that you're using. So again, I think you need to be honest that, let's say I have maybe point data of presence of trees in Ontario, but the climate data is at 1 kilometer. So there's mismatch. So I'm not answering your question again, but I think to be aware of mismatch of scale, and that if you are making conclusion, maybe you're making conclusion about smooth models and not the real data. So for those of you who are not using remote sensing is a model. So it's smooth information. So when you use that as your response variable and you see if there's a relationship with something, you test the model against another model. So what are you really telling about the reality? You maybe not. So this is just to be careful and understanding really what you're doing. I think that's the message.
I think that happens a lot, a mismatch between different types of data that we're interested in looking for those relationships. But sometimes it's also the best available data for the questions for some questions that we have. Is there, I don't know, what is the conclusion in that context? Is it just to be transparent, or
Yes.
or is there a different way to go about evaluating those questions?
I mean, transparency. Nowadays, they ask us to even upload the code that we use. So that's mean you need to be good programmer or good to have comments so that people can use your code. So that's show me your code and I will tell you your personality. It's true. How much comments do you have, and how user-friendly your code would be to others. And people are modifying code of others. So if it's not well written or it's cryptic, you cannot use it properly. So, I mean, I'm a little bit skeptical of those global things. Think the exciting thing is space-time. So what happened with space-time? So a process generates a spatial pattern. and then the process maybe change and or change not too much. So you have a volvex of space and time where the property are still valid. And then there's a change of process or another process. So then you change the uh, reality, and that's for me is of excitement, is how long do we have the same process in space and time, and when do we see a breaking point and things are changing? That's exciting. So space and time, but then this you need to do it very well. It's Noel Cressy and others have textbook on this subject, and it's very important to understand the limit of it as well.
Thank you for all of those answers. I wanted to save a few minutes for, again, audience. The audience, you go, okay, thank you.
I feel kind of bad. I feel like ending on a space-time Volvex is like the best place all of us could walk out of here. And but I want to ask kind of a finer scale network question. So something that I often find myself puzzled by when I think about ecological networks in space is how we define not the edges, but how we delimit those networks. So you have this a quandary where these networks are built, empirical networks of species with many different dispersal distances. There is no single network that is entirely isolated from other networks, just like there is no population that is entirely isolated from other populations. So that's okay. But you also have these scalar properties, or network properties scale up and are so different when networks are larger versus smaller. So I guess my question is, do you feel like we have a good grasp on how sensitive our meta network conclusions are to how we're choosing those individual networks?
Right. This is not specific to network. It's true to any, let's say, connectivity analysis. People realize there's an edge effect when you do algorithm to find connectivity among patches. So it's the same idea of there's maybe you are not finding this patch outside that are contributing. So the only way to a little bit palliate, not completely, is to have your study area and do a buffer and add other patches that will directly affect them. So that's the only way to, but I mean, it's an open system. So then the continent boundary is maybe the upper limit of what is possible. So then it's impossible to do that. But to do a buffer, let's say that is maybe proportional to the dispersal ability of the species of interest. So you say, well, I want to include only the patches that are within such distance. So you create another mesh, if you want, outside, and then, but you take the statistic only for the center.
Thank you.
Other questions? Maybe one more question? All right. Well, thank you again, Dr. Fortin, for coming for 2 days.